Air comes in to the inlet guide vanes and then enters into an axial compressor. The axial compressor consists of rotors and stators. The rotors are there to impart energy, much like a fan, to impart velocity into the air. Now that the stators trade that velocity for pressure and ensure the correct angle onto the next rotor. Now as the air goes through, in this one at stage 5, air is allowed to escape into what's called a bleed area or the bleed valve area. And that's where this attachment is. There again, here it is. The air goes in through the inlet guide vanes, making sure the angle of the air is at the right angle as it approaches the compressor. The rotors impart energy and then goes through the stator. There is 6 stages on this engine of axial compression, followed by a centrifugal compressor. You can see the inlet of the centrifugal compressor there, and it's the inner ring. That there is the inner ring of this centrifugal impeller. So the centrifugal impeller imparts energy by spinning and forcing the air out, imparting velocity into it. As the air exits, it enters into the next piece, which is called the diffuser. And the diffuser is right in there in the diffuser scroll, which is a larger piece. And it's a series of divergent ducts. So as the air leaves the centrifugal compressor, the divergent ducts trade velocity for pressure, and it reaches the highest point of pressure inside the engine. Now the diffuser scroll is this piece, or the diffuser manifold, or the compressor manifold, and it's used to divert the air to the correct direction. If we have a look inside it, you can see it has turning vanes in there. And those turning vanes are used to make sure that the air gets around that corner nice with less loss in velocity and pressure as it moves towards the back of the engine. There's also a few other things on the diffuser scroll, and we'll get to that in a minute. As I put this compressor case half on, I'm just going to discuss a little bit about the difference between an axial and a centrifugal compressor. An axial compressor is more efficient at low speeds than a centrifugal compressor. And a centrifugal compressor is more efficient at high speeds than an axial compressor. So therefore, during normal operation at low speeds, a bleed valve is required. So this bleed valve, when it's open, increases the flow rate across the axial compressor, preventing the angle of attack getting too high on the blades and resulting in a compressor stall. I'll make another video on that at a later date. Now, here's how it works. So the air comes off the compressor scroll and enters into the top of the bleed valve. Inside the bleed valve is a orifice, and that orifice uses it's a sonic venturi, and when the speed of the air reaches a supersonic speed, it'll close the bleed valve. Now over here we have the anti-icing system. So when the anti-ice system opens, it allows compressor discharge air, which is hot air, to enter into these vanes. Now the inlet guide vanes, preventing them from getting ice on them. Now there's 2 inlet guide vanes that are heated by oil, one on the top and one on the bottom, oil into the number 1 bearing and out. Now this line here is the pressure line going in, which is usually a smaller line, and then there is a larger line going out and to the scavenge area where the oil is taken back. Now be careful not to do this. Make sure you back up all your B-nuts when you remove them. I didn't even know that can happen until I saw that there. Okay, so now back to the diffuser scroll. We can see the customer bleed port. This engine has 2 customer bleed ports, and this is where the airframe manufacturer can tap in to the diffuser scroll and take that high pressure air for it to be used on the airframe. Also, the engine itself this one has a hydro-pneumatic fuel control. So it needs to get that compressor discharge air so that it can tell how much fuel it's using. Now this one has a filter on it, and you can see where it comes up, goes through the filter, and then back to the fuel control. So now as air comes out, it goes through those turning vanes and then out through the diffuser tubes towards the back of the engine. It's here where it enters into the outer combustion liner, And in the outer combustion liner, it has provisions for a spark igniter and a fuel nozzle. The fuel nozzle is in the middle so that it injects the fuel directly into the main path. We also have two drains on this one. One's at a 45-degree angle for installation in an MD500 where the engine sits on an angle, and the other one is for normal use. Now here's pulling the spark igniter out. So the spark jumps from the inside to the outside, ionizing the air and causing almost like a flash, like a camera flash. And there's some precautions when taking those out, so make sure you read the manual carefully when you pull those out of an engine. Now over here on this engine, we can see we put 28 volts in, and we get 10,000 plus volts out through this cable and back to the engine. Now this will snap periodically, lighting off the fire inside there. Now in order to get a fire, we also need some fuel. So this is the fuel line. If you followed it back far enough, you would see that it comes off the fuel control unit up in here. It comes off the fuel control unit. You can follow those lines back and is introduced into there. Now, back to this other one. One of the things that we want to be careful of is that we never pull both of them out. The burner can fall down on the inside. The inner combustion liner can fall down. So here I'm going to reinstall the igniter plug before I take out the fuel nozzle. So now removing the fuel nozzle. This is a duplex style fuel nozzle, which means it has two flow patterns. Inside this is a little spring and a valve that when the fuel pressure gets high enough, it will change the flow pattern. The holes on the outside are for air cooling, and the two holes on the inside are for fuel. So a duplex. Here I've removed the outer combustion liner, and you can see where the air enters. The transfer tubes enter there, and then you have the spark igniter and the fuel nozzle in the back and the drain at the bottom. Air enters into those large holes on the combustion liner, the outer combustion liner. Now here I have the inner combustion liner installed into the outer combustion liner, and you can see how air would then enter in from the outside through the louvers that are inside this guy. So the liners that are the inner liner here has louvers on it, and those louvers are situated so that they point in different directions, and they end up getting a swirl going on with the air, and as the air swirls, the fuel air mixture will be mixed better, and the flame will be slowed down so that it is out before it reaches the next part of the engine, because if the flame touches the sides of this, it will melt holes in it. You can see this burner can got quite hot on the edges. So there's a bunch of the holes. You can see where that secondary air goes in. So the air that goes in and is combusted, about 25% of the air that goes in is combusted, and they call that primary air. And all the rest of the air, the 75%, is for cooling. These engines are air cooled on the inside, even though that compressor discharge air comes out at about 400 degrees Celsius, which is a lot cooler than the 1500 degrees in the combustion chamber. This here is a convergent duct which trades pressure for velocity and introduces the air at the correct location to enter into the turbine stages. So each turbine stage starts with a stator, and the stator here is also called a turbine inlet guide vane or a turbine nozzle, and the air goes into the nozzle where it increases in velocity and is set at the right angle onto the first stage rotor. So we have a stator in the front, and then a rotor, and that makes up one stage. And that'd be the first stages always are used to drive the compressor because it needs to continue operation of the engine. So in this we have stator, rotor for the compressor, and stator, rotor for the power section. So I'm going to look in the back. Because it started with a stator, it's going to finish with a rotor, and you can see there's the power turbine. Now here is the exhaust section as well, and the exhaust section is just directing the air out of the engine, and at that point right there is where the airframe starts. So the engine stops right at that nozzle and the airframe starts. Now let's just do a quick recap of the theory here. So air is going to go in through the inlet guide vanes into the axial compressor, where it goes in, then goes into the centrifugal compressor, out through the diffuser, and the diffuser scroll into the transfer tubes, back into the combustion chamber, and then once it's done there, it goes compressor turbine, power turbine, and then out the exhaust pipe. I hope you find this video useful. If you have any more questions, please just post them into the spot below and I'll do my best to keep up with them.